brought to you from the third row in the back of the class, where the cool kids apparently hang out. 5.4 is properties of logarithmic functions, and we're going to do these two things. We're going to convert logarithms, products, powers, and quotients into an individual log. All these words mean take a single log and rewrite it as multiple logs, and then take multiple logs and rewrite them as a single log. So we're going to be doing some simplification. And then the second part is simplify the expressions log base a of a to the x and a to the log base a of x. These are the two objectives that we want to take care of today. So this is the product rule. Log base a of m times n equals log base a of m plus log base a of n. I like to use parentheses when I use the logs, and I wish that the textbook used parentheses as well, so that way you know what you're taking the log of. Because the log is a function. It's a function of something, kind of like f of x. So when you write f of x, it's always f of x, right? You use parentheses. You don't write f of x that way. So log is a function, so they should really be putting parentheses around this stuff. You can take a single log, like the example up here, and rewrite it as multiple logs. So you can rewrite this as log base 2 of p to the third plus log base 2 of q. So you can also use this rule in reverse. So if you have multiple logs, like log base 2 of 5 plus log base 2 of 6, you could take these two logs and, using the product rule, condense them down to a single log. That would be log base 2 of 5 times 6, which of course is log base 2 of 30. And so the rule works two ways. You can go from a single log to multiple logs, or you can go from multiple logs back to a single log. This is the quotient rule. And for the quotient rule, quotient means division is involved. And so this is a similar rule, except for instead of multiplying, you're dividing. Instead of adding, you're subtracting. So again, I would rewrite this rule as, and I'll write it down here, log base a of m divided by n, so that's the quotient, that's division, equals log base a of m minus log base a of n. This is log base t of, and again I wish they'd put parentheses around this, 8 divided by w. So if we rewrite that, it'll be log base t of 8 minus log base t of w. That's going from a single log to multiple logs. We could also go from multiple logs, log base a of 10 minus log base a of 2. Yeah, so this would be log base a of 5. Now, if these rules look a little bit familiar, they should, because there's some rules that you learned a while ago that are very similar. So for example, x to the third times x to the fifth. What is that equal to? X to what power? X to the 8th power. What do you mean 8th power? How did you get an 8? These are multiplied together. Shouldn't it be 3 times 5? And you learned a long time ago, no, that when you have like bases that are multiplied together, again, multiplied together, you add the exponents. And you also probably saw a problem that maybe looked like this. X to the 15th power divided by x to the third power. What is that equal to? X to the 12th power. It's not x to the 5. You don't divide them. But there's division there. Aren't you supposed to divide them? Not with the exponents. When you divide exponents, you subtract. When you divide like bases, you subtract these. When you learn these rules of exponents, it took you a while, but eventually you learned that, oh, what you have to do is you say 3 plus 5. You add them. Even though the operation is a multiplication, in order to simplify, you have to add your exponents. And you also said 15 minus 3. You had to subtract them. Why? Because the 15 was on the top and the 3 was on the bottom. and these are exponents. What is the undo of the exponent? The log. So the rules for exponents also apply to the rules for logs, and that's why this feels familiar. When you do a quotient dividing, you subtract. So these are two rules, product rule, quotient rule. The third rule is called the power rule, and this one's pretty simple. It involves a log with an exponent, and again, I wish they would rewrite this. So we'll write it up here. Log base A of m to the p power. And what you're going to do is when you have a log and an exponent on the thing you're taking the log of, you can take this exponent and drop it down in front. So this will become p times log base A of m. So this is kind of a simple rule. So let's look at these three examples. Log base A, so this is log base A of 11 to the negative third power. We're just going to take this negative 3 and we're going to move it right in front. So it'll become negative 3 times log base A of 11. For the next one, this is log base A of, this is the fourth root of 7. Yeah, 7 to the 1/4 power. You want to convert it into exponential notation. And then what's going to happen to that 1/4? To bring it down in front. So you're going to take this 1/4 and you're going to drop it down in front. So this will become 1/4 times log base A of 7. Or if you're really fancy, you could say log base A of 7 divided by 4. And then finally the third one, natural log of x to the 6th power. Again, you're just going to take this 6, drop it down in front. So it's 6 times the natural log of x. Here are three example problems that we're going to take a crack at. So let's look at the first one. So A is going to be log base A of x squared times y to the 5th divided by z to the 4th power. And when you look at this, you're going to notice three things. You're going to notice an x term, you're going to notice a y term, and you're going to notice a z term. So we're going to kind of handle these individually, sort of like in our head. So we're going to break this into three parts. There's going to be an x, a y, and a z. So let's start with the x. So this will be 2 times log base A of x. So we use the power rule to move the 2 down in front, and then the next thing we're going to do is we're going to move on to the y, and so we have to use the product rule. So this is x times y, so we're going to put a plus here, 5 log base A of y, and then minus 4 log base A of z. So here's where we simplified the x term, here's where we simplified the y term, and here's where we simplified the z term. And it's important to notice that the z term has a negative in front of it. So what the sign indicates in front of each one of these, what the sign indicates is its location in the fraction. So anything with a positive in front of it, those are in the numerator. And anything with a negative is in the denominator. All right, let's take a look at B. So the second problem is, and this is in radical format, it's given to me in radical. Let's convert it right into exponential. So this is log base A of A to the 2nd, B divided by C to the 5th, all to the 1/3 power. So the first move is to go from radical format to exponential. Then we're going to use the power rule. We'll take this 1/3, we'll drop it down in front, so it equals 1/3 times a whole bunch of stuff. So again, we've got three variables here. We've got an A, we've got a B, and we've got a C. And we're going to handle them one at a time. So when we simplify the A using the product rule, it'll be 2 log base A of A. And then move on to the B. So since the B is in the numerator, we're going to put a plus There's no multiplier on that, so that's just log base a of b. And then the c is in the denominator, so we'll say minus 5 log base a of c. And then as a final move, we'll distribute that 1/3 inside of everything. And again, here's your a term. This is log of a. Here's your b term, and here's your c term. And so this one has 4 components, and we'll just take them one at a time. Log base b of a, that's pretty easy, plus 5 log base b of y, minus 3 log base b of m, minus 4 log base b of n. And one thing to notice is that m and n both have negative signs in front of their coefficients because they're in the denominator. They're using the quotient rule. Now let's run it the other way. Let's take an example of something that is multiple logs and condense it down to a single log. So again, you're going to notice I got an x here, I got a y here, and I got a z here. So there's 3 components to this. They're all to log base b, so that's good. Log base b of, and then just handle them one at a time. You're going to take the 5 that's out in front of the x, and you're going to make it a superscript, so that's x to the 5th power. Where's the y going to go? Yeah, y goes on the bottom. Does it have a superscript? Nope, no superscript. So y goes on the bottom. And then z, so this is actually z to the 1/4 power, because you're going to take this 1/4 and you're going to kick it up top here. And z to the 1/4 is the 4th root of z. So we're just going to write times. Now does this z go on the top or on the bottom? It goes on the top. Why? Because it's a plus. So the plus means things go on the top. 4th root of z. What if, and I'm going to change this problem just a little bit, I'm going to put parentheses around these. So where does the y go? On the bottom. What about the z now? Now the z would go on the bottom because you have to distribute this negative to both places. So be careful of parentheses. This means divide by the product of y and z. So in this case, the 4th root of z would go on the bottom. How do we do problems if we don't have a calculator? Well, maybe we can give you a little bit of information. And that's what this is. This is a really good problem. They're starting out by telling you that the log base a of 2 is equal to this decimal, 301 thousandths, 0.301. And they're also telling you that the log base a of 3 is approximately this decimal. Now we don't know what a is. They're just giving us this information. And then they're saying, find out what log base a of 6 is. You say, I don't know, you didn't give me log base a of 6. You only gave me log base a of 2 and log base a of 3. Ah, but is there a way that you can make a 6 using the 2 and the 3? Log base a of 6, and this is part A that we're doing here, log base a of 6 is equal to log base a of 2 times 3. And then if we break that apart using the product rule, it's log base a of 2 plus log base a of 3. And what is log base a of 2? 0.301. What is log base a of 3? 0.477. And what do I have to do with those? Add them up. So this is what it's equal to. Log base a of 81. So how can you create an 81 using only 2's and 3's? 3 squared times 3 squared. This would become 2 log base a of 3 plus 2 log base a of 3. We're taking this 2 and we're dropping it down in front. We're taking this 2, we're dropping it down in front. That's where those come from. And we know what log base a of 3 is. So this is going to be 2 times 0.477 plus 2 times 0.477. 1.908. Log base a of 1/4. So how do you represent 1/4 using only 2's and 3's? Well, we know that 2 squared is equal to 4, and remember that negative exponents reciprocate. So 2 to the negative 2 is equal to 1/4. So this becomes log base a of 2 to the negative 2 power, which is negative 2 times log base a of 2, 0.301. So that's negative 0.602.
How did you get that negative?
If you have log base a of a to the x, the base of your exponent and the base of your log match. If they're the same, then they kind of cancel each other out. And if you want to see sort of an example of this, or this idea, if you say log base a of a to the x, well, you can take this x and you can drop it down in front. So that's x times log base a of a. And what does this mean, log base a of a? It means a to what power equals a? Well, that's a 1, right? So a to the first power. So this whole thing is actually equal to 1. So that's x times 1, which is just x. So example A, log base a of a to the 8th, and again I'd write this as log base a of a to the 8th power. That's just 8. Log base e of e to the negative t power. So once again, the e and the log and the e and the exponent cancel each other, and you just get a negative t for an answer. And then finally this last one, log, that's the common log, so that's base 10 of 10 to the 3k power. So again, the base of the log and the base of the exponent, and you're just left with 3k. If you have an exponent that involves a log, and once again the bases match, they kind of neutralize each other, and you're left just with an x. So here you have the base of the exponent, and here is the base of the log, and they're going to kind of cancel each other out, and you're going to be left with k. On the next one, this is e to the log base e of 5. Remember, that's what natural log is log base e. And again, these two things are going to kind of cancel, and you're just left with a 5. And then finally, here's the common log. So this is 10 to the power of log base 10 of 7t. And the exponential base and the logarithmic base kind of cancel each other, and you're just left with 7t. Convert logs with products, powers, and quotients. That's using the product rule, the power rule, and the quotient rule. Check. And then simplify expressions of the type log base a of a to the x and a to the power of log base a. This again is where your bases kind of cancel each other. Check, check, check.